Today we are going to be looking and working with geometric sequences. A geometric sequence is the set of numbers created by repeated product of a common ratio. A common ratio is a common multiplier to create geometric sequences. So let's look at our first three examples. We want to determine if they are geometric. So let's take a look. If we start at 5, then we're going to 15. So I know I'm multiplying that by 3. 15 times 3 is 45. And 45 times 3 is 135. So yes, this is a geometric sequence, and we're multiplying by a common multiplier of 3. So number 2. 15 times 2 is 30, but 30 times 2 is 60. So we know this is not a geometric sequence because we are actually adding 15 to all of these. Alright, so let's take a look here. If we wanted to determine if this was going to be a geometric sequence, I'm going to say, okay, well, 20 divided by 8 is 2.5. So 8 times 20 is 2.5. Or sorry, 8 times 2.5 is 20, but 20 times 2.5 is 50. So if I take a look, we're actually adding. So this is going to be an arithmetic, so no, this is not geometric. Let's look at the formulas. We have our recursive and our explicit. A1 still stands for our first term. NSOLD stands for the number of term we're looking for. And R is going to be our ratio. What's the common multiplier that's being multiplied? So let's take a look at this first example. We want to write the explicit formula and then generate the first 5 terms. So we're going to have that AN equals, our first term is 40, our ratio is -2, and we're taking it to the n minus 1 power. So that's our explicit formula. So let's find the first 5 terms. We know the first term is 40. So to find the second term, we would say, well, the second term will be 40 times -2 to the 2 minus 1, and 2 minus 1 is 1. So -2 to the first power is -2, and 40 times -2 is -80. So if we keep continuing that, a to the third would equal 40 times -2 to the 3 minus 1. And when we get that, we're going to end up with a positive 160. A to the fourth would be 40 times -2 to the 4 minus 1. 4 minus 1 is 3, so -2 to the third times by 40. -320, and to find our fifth term, 40 times -2 to the 5 minus 1, so 5 minus 1 is 4, so -2 to the fourth times 40, and it's our fifth term is 640. So let's find the 17th term of this geometric sequence. So if I want to find the 17th term, my first term is 11. To go from 11 to 33, we're multiplying by 3. And 33 times 3 is 99. So our ratio is 3. We want to find the 17th term, so it's 17 minus 1. So our 17th term is going to equal 11 times 3 to the 16th power. And 11 to the 16th power, or sorry, 3 to the 16th power is 430. Is 43,046,721. And when you multiply that by 11, our 17th term is 473,513,931. Alright, let's take a look at the back side.